Hello everyone, my name is Atharv Chauhan. So today I'll be discussing two very important topics in data science, how to handle missing values and how logistic regression works. Because both of these are essential for building clean data sets and accurate models. I'll explain everything in simple and practical manner so it's easy to understand. To be precise, this is the question number 6 of our end sim paper, and this is the sixth part of solution video. So let's dig deep into it, considering both part A and part B. Part A for handling missing values and part B for logistic regression. So let's see what we'll cover today. First, why missing value occurs, then different types of missingness, then methods to handle missing data, and finally we learn about logistic regression and how it predicts probabilities. So let's start with missing data, something all real-world data sets struggle with. Now, missing values are unavoidable, but understanding why they occur helps us choose the right method to fix them. Common reasons include sensor failure, devices malfunction or stop recording, human entry mistakes, skipped fields or typing errors, data corruption, issues during storage or transmission, dataset merging, mismatched records when combining sources, optional fields, survey questions left unanswered. So missing values are rarely random. There's always a story behind them. Now let's discuss the type of missingness. So types of missingness. Before choosing a technique, we must know what type of missingness we are dealing with. So MCAR, missing completely at random. No pattern, data is missing purely by chance. MAR, missing at random. Missingness depends on other observed variables. Example, income missing more often for people with low education. MNAR, missing not at random. Missingness depends on the missing value itself. Example, people with very high salaries choose not to reveal it. Identifying the type helps us avoid bias and choose the right method. Now, let's discuss the handling technique number one, deletion methods. First, list-wise deletion. We remove rows that have missing values. Useful when missing data is less than 5%. Data is MCAR. It's simple but reduces dataset size. Then, pairwise deletion. Uses all available data for each analysis without deleting entire rows. It keeps more data but can lead to inconsistent sample sizes. Now let's discuss handling technique 2. Simple imputation. Simple imputation replaces missing values with a single statistic. It can be a mean imputation for clean numeric data, replaces missing values with average. It can be a median imputation for numeric data with outliers. It's more robust than the mean. It can be a mode imputation for categorical data, uses the most frequent category. Now the pros is it's fast, easy, and no data is lost. But the cons is it distorts distribution and ignores relationships. Let's discuss handling technique number 3, advanced imputation. So advanced imputation consists of kernel imputation, finds similar rows and uses their values to fill missing data, which is more accurate and preserves patterns. Then we have regression imputation, which predicts missing values using a regression model, uses relationship between variables and can be very precise. We have multiple imputation, generates multiple versions of data set and combines results, more statistically reliable, handles uncertainty well, and computationally it's a bit heavy. Now we have technique number 4. Domain based handling. This approach uses business knowledge on natural constants, example, expert driven replacement, company rules or industry standards, seasonal or physical bonds. The best results often come from combining domain expertise with statistical methods. Now, what is logistic regression? Now, let's move to logistic regression. Logistic regression is a classification algorithm which predicts probability of belonging to class 0 or class 1, uses the sigmoid function to squash values into a range between 0 and 1, uses zero point 0.5 as a natural decision boundary. Real world application includes spam versus non spam, disease diagnosis, and customer churn prediction, loan approval decisions. It's simply powerful and widely used. Now let's discuss logistic function with example. The sigmoid function converts any real value into probability. We compute z equals to b naught plus b1 plus x1 plus b2 x2 plus, and the series goes on. Worked example is, given we have z equals to minus 2 plus zero point 0.5 multiplied by 8, so we have z equals to 2. Applying the sigmoid function, we get p equals to 0.8807. This means the model predicts an 80% probability that the observation belongs to class A. Since 0.88 is greater than 0.5, we classify it as class 1. Now let's talk about the final summary. To wrap up, missing values happen for many reasons. MCAR, MAR, and MNAR helps us identify the pattern behind missingness. Deletion, simple imputation, advanced imputation, and domain-based method help us to fix those missing data correctly. Logistic regression is a simple and effective classification algorithm that outputs probabilities with a sigmoid function. So yeah, that is for this solution video. Thank you for listening. Thanks for watching.